In solid mechanics, the use of pictures for quantitative measurements, also called photomechanics, is an activity that started more than 20 years ago in our lab. Thanks to digital image correlation, it's now possible to have access to huge amounts of data, typically 10,000 to 100,000, compared to a limited number available through classical methods. This allows for a better identification of the parameters in mathematical models used to describe the behavior of materials in structural computations.
Within the IDS R&D Center, we are focusing on new methodologies enabling the so-called virtual testing approach to be mastered to structural analysis. The aim is to give more confidence in numerical simulation from coupon to structural case. Digital image correlation-based devices are very useful to tackle this goal since they enable strong links to be created with simulation, identification and validation, and also quantitative full-field measurements, which is a new maturity gap from the industrial point of view. In that sense, ADS IW fully supports the initiative and will conduct further developments within the framework of a long partnership with LMT Cachan.
Digital image correlation techniques have now reached a degree of maturity that makes their transfer possible. There is a need to go from a research tool to a software that can be used by engineers. This is the rationale behind Tcics project.
Thanks to its scientific excellence and its interest for the industry, the Tcics project was granted by the Innovative Technology Transfer Readiness Program proposed by Digiteo, the OMT. The objective of this program is to enable and speed up transfer to the market of results coming from research programs. There is a yearly call for projects inside the cluster, and the innovation are supported under three aspects: marketing, to assess the market potential and define the business model; legal, to evaluate the patentability and the freedom to operate of the technology; and technology, to realize a demonstrator.
We work on a prover aiming to give a friendly and convenient access on what we hope to be the full power of image correlation, starting from the management of the data on the devices to the exploitation, in terms, for example, of sensitivity analysis or identification of mechanical and geometrical properties. Digiteo hired an engineer who helped us to develop an interface linked to a correlation code that was written in our lab. It permits to decrypt the data for 2D or 3D components, virtually allowing the determination of mechanical properties for any type of part or material. It can use, depending on the case, standard or high-speed digital camera images or tomography images.
Within Lafarge, world leader in building materials, one of our main concerns is to characterize material properties using non-destructive methods during tests. We have been using digital image correlations as a measurement tool or as a global failure mode characterization for more than 4 years. One of its limits is that a good level of expertise is necessary to use available software. We are really interested in a real-time and end-user-oriented software. We see the positive move made by this interface to facilitate the handling of these leading-edge correlation techniques.
It can be used for different kinds of material, including ceramic and glass, elastomer and polymers, steel and alloys, construction and geomaterials, composites, and so on. Tcics software significantly reduces the amount of overall testing time by eliminating the need of strain gauges, extensometers, and external additional computations.
The market survey confirmed what he had imagined in terms of interest for industrial applications, both for international companies and SMEs. It emphasized that the determination of the mechanical properties of 3D parts is a major innovation. In parallel, patenting opportunities were also considered. These two aspects are not that classical in universities and would not have been conducted without Digiteo's support. We have a clearer view of the market value of the innovation. This validates the strategy of our lab in terms of future research projects, for instance, the validation of the proposed models.